Hello everyone, welcome to another session of CSEC Chemistry. Today I'll be presenting the solutions to May-June 2015 Paper 2. Question 1, which is on the topic Organic Chemistry, first of all, mentions that hydrocarbons are widely used as fuels. They burn in oxygen to form carbon dioxide and water. Also, energy is released in the process. You're asked firstly for 2 marks, list 2 natural sources of hydrocarbons and also name 1 hydrocarbon other than wax that can be used as fuel. Now, for the natural sources of hydrocarbons, natural gas and crude oil were the expected answers for this question. Asphalt, fossil fuels, those are also accepted answers. In terms of hydrocarbon other than wax that can be used as fuel, either ethanol, gasoline can be considered that hydrocarbon. Part B of the question reads that a student carried out an experiment in order to determine the heat of combustion of candle wax, which is a mixture of solid hydrocarbons, by using the apparatus shown in the figure below. The procedure for the experiment is given as shown on screen, and you're asked to take some readings from different apparatus and record them in a given table. So the first apparatus that you had to read off here is the balance, and you have to take the mass of the empty conical flask. That reading is going to be 125 grams. Next, you're asked to record a reading for the mass of the conical flask and water. And looking at the balance given there, the reading will be 326 grams. Next figure there, ask you to take the thermometer reading to give the temperature of initial temperature of the water in degrees Celsius, and that is going to be 27 degrees Celsius. After that, you're asked to find or report rather the final temperature of the water in degrees Celsius, looking at the thermometer shown, that is going to be 39 degrees Celsius. Our next figure there is showing the initial mass of candle and watch glass, and taking the reading, it is going to be 97.5 grams. And the final figure showing the final mass of candle and watch glass, that reading there is 96 grams. Now, using the information that we'll have just obtained from the apparatus, we can now calculate what is the mass of water used by subtracting those two values, 326 minus 125, which will equal to 201 grams. We can find our temperature change, which is going to be 12 degrees Celsius. And the mass of candle burned can be calculated by subtracting 96 grams from 97.5 grams, which will be 1.5 grams. So completing that table there will give you 9 marks. Part 2 of the question here tells us, assuming that the heat absorbed by the conical flask can be calculated using the formula given there, mass of the conical flask multiplied by 0.86 joules per gram per degree Celsius times temperature change, you're asked to calculate the heat absorbed by the conical flask used in the experiment. So the mass of conical flask will be 125 grams. multiplied by 0.861 joules per gram per degree Celsius, multiplied by a delta T of 12 degrees Celsius. Working this through here, you should have an answer of 1291.5 joules. Part 3 of the question. It says there, assuming that the heat absorbed by the water can be calculated by the formula mass of water in a conical flask times 4.2 joules per gram per degree Celsius times our delta T, or change in temperature, you're asked to calculate the heat absorbed by the water in a conical flask. So working this through here, we're going to have 201 grams multiplied by 4.2 joules per gram per degree Celsius multiplied by 12 degrees Celsius. Working that through, you should have an answer of 10,130.4 joules. Part 4 of the question asks us now calculate the total heat absorbed by the calorimeter, and you're given a formula there. So just substitute into that formula, we're going to have 1291.5 joules plus our last answer there, 10,130.4 joules, which will give us a total of 11,421.9 joules. Part 5 of the question here now asks us to calculate the heat of combustion of the candle wax. Again, we are given the formula, so we just substitute in our previous answers into the formula. Alright, so total heat will equal to 11,421.9 joules divided by the mass of the candle burnt. We'll have calculated that in a table, which is going to be 1.5 grams. Working that out, you should have an answer of 7,614.6 joules per gram. We are asked also what was the role of the can in this experiment. Simply it was that the can was used to reduce the amount of heat being lost to the environment. Part C of the question focuses on the topic qualitative analysis. So question introduces this part here by saying a student carried out a number of tests on a solid mixture labeled Q. Some of the observations and inferences are recorded in the given table. You're asked to complete the table by inserting the inferences or observations as necessary. So part 1 of this table, working it through here, it tells us here that Q, first of all, is heated strongly in a boiling tube. Observation being brown fumes are seen around the mouth of the boiling tube. So the brown fumes here will indicate that it is nitrogen dioxide has been our inference, or we can also say that it was a nitrate salt being present in the boiling tube. Secondly, glowing splint is placed at the mouth of the boiling tube. The glowing splint is rekindled, that is indicating that oxygen gas is present. All right, so O2 gas present. The gases evolve or bubble into aqueous calcium hydroxide. Observation being a white precipitate is formed. So we can say it is going to be carbon dioxide gas being produced, or also again we can say that Q contains a carbonate. Or so we can say carbonate ions are present. Part 2 tells us that dilute hydrochloric acid is added in excess to Q and the mixture warmed. To the resultant solution, aqueous sodium hydroxide is added until in excess. The observation is that a green precipitate is formed, which is insoluble in excess sodium hydroxide. So apart from writing inference, you're also expected to give the ionic equation. So green precipitate there will indicate the presence of Fe2 plus ions. All right, and the equation is going to be Fe2 plus aqueous plus 2 hydroxide ions, aqueous to give us iron hydroxide, which is solid. All right, so that is the ionic equation that was required for this part of the question. Remember that whenever you're writing ionic equations, to include your state symbols, all right, you can lose a mark for the absence of state symbols when writing ionic equations. Part 3 of the question gives us 3 tests or 3 parts of a test. And the inference is that chloride ions are present. So when chloride ions are present, whenever we add dilute nitric acid followed by a few drops of silver nitrate, we should see a white precipitate. If the test tube is left for standing in light for 5 minutes, that white precipitate will change to light purple. And ammonium hydroxide was then added to the resultant mixture. What is going to happen if chloride ions are present? That precipitate will be soluble. Good, so this will bring an end to question 1, which is worth 25 marks. We now move on to question 2. Question 2 introduces or starts out water exists in 3 states of matter, while iodine only exists in 2. If you are to list the 3 states of matter in which water exists, that is simply going to be solid, liquid, and gas. Part 2 of the question. Describe the strength of the forces of attraction present between the particles in each of the 3 states that you'll have mentioned. So here you'll have to compare solid, liquid, and gaseous states in terms of forces of attraction between the particles. So in solid state, they have very strong forces of attraction between the particles. Liquid state, we have forces of attraction being strong but not as strong as present in a solid. Gaseous state, forces of attraction between the particles are very weak. Part 3 of the question says, when heated, iodine changes from one state into another. What is this process called? that is going to be sublimation. And you're asked to describe how the energy of the iodine particles changes as iodine undergoes sublimation. So when the iodine particles are in that solid state, the particles vibrate only and have very little amount of energy. And when they change into the gaseous state, the particles will move faster and have a greater amount of kinetic energy. Part B of the question says, using appropriate diagrams, you are to illustrate how the bonding in sodium chloride differs from that of diamond. So in sodium chloride, you're expected to mention that we have ionic bonding, whereas in diamond we have covalent bonding, and you're to draw the the diagrams here as shown on the screen. Part C of the question reads, describe two tests that are performed in the lab to distinguish between an ionic solid and a molecular solid. You're also to suggest how the results of the test described can be used to distinguish between the two solids. So I have three tests on screen there. You're just required to state any two. So the first one we can do is test for solubility in water. Ionic solid will dissolve in water, whereas the molecular solid will not dissolve in water. We can use a test for solubility in organic solvent. In this case here, the ionic solid will not dissolve, whereas the molecular solid will dissolve. We can also do a test for electrical conductivity. And it says here that with a solution of the sample or molten substance, you're to use an electric current to determine if a bulb will light to verify conductivity. Ionic substance in the solution form or molten form will conduct electricity, whereas a molecular substance will not conduct electricity. Good, moving on to question 3. So you're given the structure of two compounds, compound A and compound B, and you're to state which series do each one of them belong to. So compound A, we can see that how it has carbon-carbon single bonds present throughout, which would indicate to us that's an alkane because they're only carbon and hydrogen. Well, the question will have indicated that they're hydrocarbons with carbon and hydrogen only. So once we have carbon-carbon single bonds here, that's going to be alkane. In compound B, we notice that there is carbon-carbon double bond present. So that compound is going to be an alkene. For this part of the question now, you're asked to give the name of compound A and give the name for compound B. So let us name compound A first. So first of all, we want to name that straight chain. All right, so we have 4 carbons present, so that is going to be butane. We then look and that there's a branch. It has 1 carbon in the branch, so that's going to be a methyl group. And then looking at the carbon that that branch is present on, we see that that's the second carbon. All right, if we come from left to right, that is going to be the second carbon. If we come from right to left, that will have been the third carbon. And remember that we're taking the smaller number when we're naming the branch part of the hydrocarbon. All right, so that is going to be 2-methyl butane. For compound B, again, we see that it's 4 carbons, so that's going to be bute, and because we're naming an alkene, we're going to put the number in between there, and then we put our ENE. So if we look at it, this is going to be 1, 2. If you count them the other way, and it will have been 1, 2 also. All right, so it's 1, 2, 3, 4, or 1, 2, 3, 4. So in either way, we see that 2 is going to be that smaller number there. So this is going to be bute 2-ene. All right, some books you will also see that they name it 2-butene. Part B, part 1 of the question asks us to define structural isomerism. Structural isomerism is simply defined as the occurrence of organic compounds with the same molecular formula but different structural formula. Next part of the question will ask us, you are to draw the fully displaced structure of one structural isomer for each of compounds A and B. So for compound A, we can have all 5 carbons in a straight line, straight chain rather. Right, so this will have been one isomer. And remember that in an exam, that when you're drawing your structures, do not leave out the hydrogens, right? Don't just draw a dash and say, you know what, it's understood that there's a hydrogen attached here. Ensure that you're drawing out all of your hydrogens. Another possible isomer for this could have been 3 carbons in a line with 2 carbons here. All right, so this will have been hydrogen, hydrogen, hydrogen here, carbon. That's an hydrogen. All right, let me just draw a line here to separate them. Good. So those were the 2 possible answers. Remember that you're asked to just draw one, right? So any one out of these 2 here, you could have drawn and gotten that 2 marks. The next part, we have to draw an isomer of compound B. So this could have been one possible isomer. And another possible one could have been, let's see, 3 carbons in a line with a branch. Right, and you have to be very careful, especially with our alkenes, that you ensure that your carbons they carry 4 bonds, right? The alkenes, you can see that very clearly, but you have to count especially for the carbon that is carrying the double bond. All right, so I'm just separate them again. So any one out of those 2 structures will have been correct for your isomer. Part C of the question tells us that polyethylene is manufactured in Trinidad and is used extensively throughout the Caribbean. Define the term polymer for 1 mark, and also for another mark, identify the type of polymerization that is used in the manufacture of polyethylene. So polymer, that is defined as a compound made when monomer units chemically join into long chains, we call that macromolecules. And the type of polymerization that is used in the manufacture of polyethylene will be addition. Part 3 of the question for 2 marks, so it's 1 mark each. You're asked to state 2 uses of polyethylene. So for every use, you're going to get 1 mark there. And also you're to state the name of 1 other polymer. Possible answers there for uses. You can have to make plastic bags, to make ropes, food containers, buckets, toys, any 2. And there's a wide range of answers for part 4. I have on screen there 3 possible answers: PVC, polyvinyl chloride, polypropylene, or polystyrene. All right, so any one of those or another correct response will give you that 1 mark there for your name of other polymer. So that is the end of question 3. We're moving on now to question 4. So question 4 says that Tums and Epsom salts are the items commonly found in most household medicine cabinets. Calcium carbonate is the main active ingredient in Tums. Tums is an antacid that is used to relieve heartburn, acid indigestion, and upset stomach. For 5 marks, you're asked to describe 1 method for the preparation of dry calcium carbonate in the lab. In your answer, you're also required to include an equation for the reaction as well as the steps that are involved in its preparation. Good, so we now go on to question 4. Question 4 says that Tums and Epsom salts are items commonly found in most household medicine cabinets. Calcium carbonate is the main active ingredient in Tums. Tums, there is an antacid that is used to relieve heartburn, acid indigestion, and upset stomach. You're asked there for 5 marks to describe 1 method for the preparation of dry calcium carbonate in the lab. In your answer, you are to include an equation for the reaction as well as the steps that are involved in the preparation of the dry calcium carbonate. So step 1 is going to be to combine the suitable reagents. Suitable reagents will be calcium chloride and sodium carbonate. We next will filter the precipitate. Step 3, wash precipitate. And step 4, dry the precipitate. The precipitate being the calcium carbonate. So an ionic equation is given on screen, where we have calcium 2 plus ions, aqueous, plus carbonate ions, aqueous state again, to form solid calcium carbonate. Part 2 of the question now tells us that the main ingredient in Epsom salts is magnesium sulfate. List 1 use of Epsom salts for 1 mark. And part 3 there for 3 marks. In order to effectively use Epsom salts, it is usually made into a solution. You are to explain why water molecules are able to dissolve Epsom salts. So some common uses of Epsom salts are: it is used as a laxative, it is used for treatment of arthritis, and also used for swelling of joints. All right, so any one of those will give you 1 mark. In terms of why it is usually made into a solution, why water molecules are able to dissolve Epsom salts, it is because water is a polar substance and is able to dissolve ionic compounds. Magnesium sulfate is an ionic compound and hence will dissolve in water. Part B of the question says here that when magnesium ions are present in natural water, it is referred to as permanent hard water. The question is asking you to describe how permanent hard water is formed, and you're to include balanced chemical equations with state symbols to illustrate this process. So magnesium 2 plus or calcium 2 plus ions are dissolved out of rocks and they become soluble. These ions, aqueous ions, can then combine with sulfates, producing either magnesium sulfate or calcium sulfate in solution, which will lead to the formation of hard water. Your equation there will be magnesium 2 plus aqueous plus sulfate aqueous to give us magnesium sulfate. If you want also, you could have written the equation with using the calcium ions, so that will have been calcium 2 plus aqueous plus sulfate aqueous to give you calcium sulfate. All right, so either one of those two equations will have been correct. And that is going to bring an end to question 4. Question 5 gives us a flow diagram of the industrial processing of sugarcane to produce crystalline sucrose. You're asked to study the figure and answer the questions which follow. First part of the question asks us to identify process P and process Q. So looking at there, that process P is going to be clarification or sedimentation and precipitation can be accepted as correct answers. And process Q is evaporation. Other answers that are acceptable, it will include vacuum distillation or distillation. Part 2 of the question asks us state the importance of the centrifugation process, and also you are to identify product X. So acceptable answer there for part 2 will include that it removes the liquid product surrounding the crystalline sugar, or it separates the solid crystals from the liquid byproduct, which we call molasses. Part 3 there, which is asking us to identify product X, which is molasses. Part 4 of the question, it says that the bagasse produced in the factory during the processing of sugarcane, the bagasse produced is used in the factory during the processing of sugarcane. In which part of the factory is this bagasse used, and what is it used for? So the bagasse is used in the boiler house or boiler station, furnace. Any one of those 3 words can be used for that location of the place. And it is used as a fuel in the boiler station to generate steam for the production of electricity. Part B of the question. Many Caribbean islands are renowned for the quality of rum they produce. The alcohol content of a typical rum averages between 40% and 55%. Question as reads now, the part 1. During the fermentation process in the making of rum, yeast feeds on the sucrose in molasses, converting it into simple sugars, which are then converted to ethanol. You are to outline, using balanced equations, the formation of ethanol from sucrose. So all you have to state there is that sucrose is converted to glucose and fructose, and which are then fermented. The equation there being that is the fermentation equation where we have glucose to form ethanol and carbon dioxide gas. Part 2 of the question now reads, Jemina was presented with a flask that contains a mixture of diluted rum. Draw a labeled diagram of the apparatus she should use in the lab to obtain a concentrated sample of ethanol. So we're expected to draw a diagram of the fractional distillation apparatus, a label diagram that is, to indicate this process. Part C of the question says here that after accidentally leaving a bottle of wine open for several days, Jemina found that the wine tasted slightly sour. She was given magnesium oxide to react with a sample of the sour wine. Suggest the type of reaction that takes place when the magnesium oxide is mixed with the sour wine. Write a balanced chemical equation for this reaction. So the wine there, when it became sour, it actually became acidic. All right, and the ethanol will have been converted to ethanoic acid. And ethanoic acid reacting with magnesium oxide will produce a neutralization reaction or an acid-base reaction. The equation there is given on screen, where we have ethanoic acid plus magnesium oxide to give you magnesium ethanoate and water. And that would bring an end to question 5. So moving on to the final question now. Question 6 says here that Sally and Anne live on opposite sides of an island. When Sally visits Anne, she observes that the soap takes longer to lather and produces more scum. Explain to Sally why the soap may be producing more scum at Anne's house than at her house. Answer there is very simple there, that where Anne lives has hard water and where Sally lives has soft water. Hard water contains magnesium 2 plus ions or calcium 2 plus ions. We'll discuss this earlier. And these ions, they react with soap to form soap scum. Part 2 of the question I'll ask us, do we expect that Sally will get the same result if she uses soapless detergent? State a reason for your answer. So the answer there is no, and simple being that, reason being that detergents do not form soap scum. Part B of the question. Second generation detergents contain phosphates, but their use was banned because of the effect they had on the environment, particularly rivers and streams. Outline the harmful effect that second generation detergents had on the environment. So phosphates can provide nutrients or act as fertilizer, causing algal bloom or seagrass growth. This will result in oxygen being used up in rivers or streams, causing eutrophication, leading to fishes to die. Part C of the question deals with that part of the syllabus, green chemistry. And first part there asks us, what is meant by the term green chemistry? So green chemistry is defined as using principles that reduce or eliminate the use of hazardous materials in the design, manufacture, and application of chemical products. And the final part of the question asks to discuss two benefits of utilizing the principles involved in green chemistry. So we have several benefits there that you can discuss. Makes the environment safer, reduces waste, creates new jobs, reduces respiratory illnesses, and leads to an atom economy. All right, so that brings an end to this presentation of the 2015 May-June Paper 2 solutions. Kindly like the video and subscribe to my channel to receive notification whenever I do post another video. Thank you.